All right, y'all. Percents. Percent change. Lesson 3. Page 270 if you're following along the book. Percent of change, or as I'm going to call it from here on out, percent change, is a ratio that compares the amount of change to the original amount. And so here's the percent change equation. It's the final amount minus the original amount over the original amount. And so basically we use this when we want to find how much something has changed. So let's say that the price of something goes up. How much has it gone up? Well, you take the new amount and you subtract the old amount and you divide it by the old amount, and that's how much it's gone up, or if it's gone down. Or if you're let's say that you're running a 40-meter dash, or 100 meters, or 400 meters, or a 5-kilometer race, and you get faster and faster. What percent have you gotten faster? That's kind of what this is all about. Okay, let's take a look at an example. Let's say that the temperature went from 22 degrees in the morning to 30 degrees in the afternoon. How much of a percent change is this? Well, it was 22 degrees, right? And it's gone up to 30 degrees. So the final amount, where it ended up, is what's written first. And you subtract what it originally was, the original amount, and you put it over the original amount. So I'm just going to go back to the previous slide just to show you again. Now I've written all over it. The final amount minus the original amount over the original amount. Okay. That's going to give us our percent change. So how much is that? Well, 30 minus 22 is 8. 8 over 22. 8 divided by 22 is 0.4. So it's a 40% change. Is that an increase or a decrease? Well, it's an increase. And the way that you can tell that it's an increase by looking at the numbers is that this is a positive number, and a positive number is an increase. But if it was a negative number, you guessed it, it would be a decrease. Your turn. Let's say that Michelle has 52 comic books, and she went and got some more comic books, so now she has 61. Find the percent change. Well, the new amount is 61. We subtract the old amount, which is 52. We divide by the old amount, which is 52. And 61 minus 52, what is that? 9? 9 over 52. That equals the percent change, right? I'm just going to call this C from now on. And so the percent change is 0.173. So it's a 17.3% change, and it's an increase because it's asking you if it's an increase or a decrease. Great. Let's look at another example. Let's say that Daniel has 318 obsidian armors. I don't know how he got so many. And now, not how, now he has 273 armors. What happened, Daniel? Well, let's find out. 273 minus 318 over the amount now, right? Which is, the original amount, which is 318. And what is this? This is 27 and 18, 27 and 18, 27, 37, 45. So it's 45. I'm going to do it over on this side, actually. 45 over 318. And that is, this is a negative number. And so this is going to be negative 0.142. which is 14.2% decrease. It's a 14.2% decrease, or negative 14.2%, which is a decrease. Okay. Another your turn. Let's say that Team 7 had 24 points in Math Jeopardy with Mr. Chow. Then they had 28 or 18 points after Final Jeopardy. So find the percent change. Well, they had 24 points, but now they only have 18. So this is how many points they have now. This is the original amount over the original amount. 18 minus 24 is 4 plus 2 is 6, negative 6 over 24. And so this is negative 1 over 4, which is negative 0.25, which is negative 25%. They lost 25% of their point. It's a decrease. Alrighty. Let's talk about this other thing called a percent error. It's a measurement in the difference between an estimate or a prediction and the actual value. So sometimes you will think something and you'll make a guess, and you want to know how far off you are. And so what we'll do is we'll take our estimate. So let's say that I think I have about 130 students. So that's my estimate. And then I subtract my actual amount. And let's say that I actually have, what do I actually have? I forget. Maybe 120 students. And then I take the absolute value of that. So 130 minus 120 is 10. The absolute value of 10 is still 10 over the actual amount, which is 120. And that is my percent error. Okay, so it's 1 over 12. So what is that? Like, it's something. I can't remember. Okay. So anyway, that's how this works. So let's take a look at an example. Let's say that Harrison estimated that the KAS auditorium has 660 seats, but it's actually 750. So what's his percent error? Well, his estimate was 660 minus 750 over the actual amount, which is 750, and then we take the absolute value of this, right? So 660 minus 750, that's 90. Yeah, 90. Negative 90. The absolute value of negative 90 is 90 over 750. And what is that? That's 0.12, which is 12%. He was off by a mere 12%. Good guess, Harrison. Okay, your turn. Let's say that Melody estimates the weight of her new baby cousin to be 8 pounds, but the actual weight is 6.4 pounds. So we take her estimate, oops, that's an 8, minus 6.4, take the absolute value of that. It's over the actual weight, which is 6.4, and we're going to round to the nearest tenth of a percent. So we'll only want to go 3 places after the decimal if we have to. Sometimes we won't have to. And so what is that? 1.6 over 6.4, and that is 0.25, 25%. Good guess, good guess. Okay. Let's say that Philip accidentally ripped his thumbnail off when he was playing Thumb War with Tiffany. And when his thumbnail grows back, he estimates the length of his new thumbnail to be 2.5 centimeters. But the actual length was actually 2.54 centimeters, Philip. So, what is the percent error? Well, his estimate is 2.5. Subtract 2.54. Take the absolute value of that, put it over 2.54. And so this is 0.04. Is that right? I don't know, why am I second guessing myself here? Yeah, that's right. over 2.54. And what does that equal? Let's take a look. .54. Okay, so that's 0.157. We only need to go 3 places past the decimal point because we're rounding to the nearest tenth of a percent. So this is going to be 15.7%, tenth of a percent. Oh wait, no. Here we go. We round this down. Yes, I can do this. No, what am I doing? What am I doing? This is not right. There's another 0 here. 0.01. Yeah, so no, this is actually right. It's 1. This is wrong. This is wrong. Oh my goodness. Don't listen to me. It's 1.6%. Now listen to me because I'm right this time. Okay. Here's your must do. 272. Odd. Have good.